We are here in Manchester, UK. I've got Harry here from MUON3D. Upside down printers are pretty cool, right?
They are, most certainly.
But right now, if you want one, you kind of have to build one because there's not many on the market.
They're expensive.
But now we do have one on the market.
There will be one on the market in 2 months' time.
2 months? Oh, wow. That's actually a lot sooner than I thought. Okay, cool. So, Harry, what do we got here?
We have the MUON3D M1. Now, this printer is designed to pack up into a custom case that big. So you can take it with you anywhere, you can take it on plane, you can store it anywhere. You don't need to dedicate half of your bedroom to having 3D printers.
So let's just get the elephant in the room out of the way. You know, it's actually a pretty small elephant. This looks a lot like a positron.
Indeed it does. It is completely inspired by the positron, no shame about that. Fantastic project by Kralin. And what we've done is we've completely redesigned it from the ground up, but using his same design constraints he gave himself. So it can technically fit in a filament box, although I'm not sure why you want to put a £1,000 printer in a filament box, but we've designed it with incredibly good performance in mind, as you can see here. So we're able to print at 600 millimeters a second, 20,000 millimeters per second squared acceleration, and I'm not exaggerating there, genuinely. And the cooling on it, it comes from a very small, a very high speed fan that lives in there.
And it's surprisingly quiet for like a CPAP style fan.
Oh, yeah. But it is unbelievably good cooling. I mean, you tried it with your hand earlier, didn't you?
Yeah.
It is silly. And that allows us to get sub 10-minute benches out the box. And if I'm honest, I don't really know of any other printer in the world that can do a sub 10-minute benchy out of the box. You know, they all need tuning, customization, etc. 9 minutes, 30 seconds.
Content from this year's Sanjay Mortimer Rep Fest is sponsored by LDO Motors. For printer parts, kits, accessories, and more, check them out at the link in the video description.
So essentially, for those at home, this is like if you were to take the positron idea, but design a product meant to be sold from the ground up.
Yeah, we're trying to make this accessible, make it democratizable. Like when I was at university, half of my dorm room was 3D printers.
Yep.
Whereas now, if you can get one of these, you can just put it away in a cupboard. It makes it much more accessible to people as a tool rather than an entire hobby and lifestyle. It's a 3D printing laptop, that's how I like to think of it.
And what kind, are we looking at like 180 millimeters here for build volume or?
So 200 millimeters wide.
Okay.
170 deep.
Okay.
And we have 160 millimeters, but that will be 180 millimeters by the time we launch. Some easy modifications we can do there.
So this is, I'm not gonna lie, this is very Apple-esque, Mac-esque. This is aluminum, right? We have machined components here, right?
Oh yeah, these are completely machined from solid block, and we do that to ensure the machines are top quality. You know, they weigh a bit, about 3 kilos for the full machine, but they are really, really beautiful. And here's some of the machining, for example, that we have.
So this is your tool head.
So a fully direct drive that allows us to do TPU like this.
Yes.
No problem. Right.
So we have
any material.
That's really cool because you have the actual part cooling duct machined right into that, and wow.
Yeah, it's taken me 1.5 years to develop this tool head. I'm most proud of this tool head more than anything on this machine.
It is a work of art.
Thank you very much. It was incredibly difficult to fit direct drive, 45 volt power system into the whole thing. And we got force-based nozzle probing as well, so you have a perfect first layer, no Z offset calibration.
Now we have one in the box here, so we could take a look at, because these two are both running right now and happily printing away. We'll get to that later, because that's pretty cool. So this is the nice carrying case it comes with.
We just unfold.
So like the positron, it folds up, fits in a box.
Take it out as such, and it just unfolds like this.
We have a lead screw for the Z, and that meshes into gears.
Meshes into gears at the back here. For your
so your motor for your stepper is in here for your Z.
It lives in here, and that's connected by a belt.
Okay.
And we have no cable for your Z axis to really try and keep the aesthetics sleek.
Yeah, we have a ribbon cable back here.
We do. And then inside of our case, we have our umbilical cable.
This is really cool, and this is something you can't really DIY. This has to be like a manufactured thing.
So in here we have power and data, filament and air from our CPAP hose, all in one. Plugs in here, and it plugs and locks in here. That lock will come in important later. Now, this is also a very nice piece of technology. It's taken us 2 years to develop this. PEI coated, fully transparent glass that will go to 110 degrees Celsius. So you can print ASA, ABS.
Now, and this is textured PI too.
This is texture. We were experimenting with different levels of texture. So less transparent, but more texture. And we have this bed, which is less texture, but more transparent. So we're just somewhere in between them.
And that's tempered glass as well.
This is fully tempered glass.
Okay.
So,
and how does it connect?
Attachment mechanism is incredibly simple. You just
even have a nozzle wiper on there.
Drop it in like that.
There's even got a nozzle wiper on that thing.
Nozzle wiper right here. And that helps us with the nozzle-based probing.
Yep.
We're doing force probing. And again, it just drops like that. It is incredibly simple.
Is there a locking mechanism, or is it just weight?
There is a locking mechanism.
Okay.
It's magnetic, not quite on these machines yet.
Okay.
We've just been a bit set behind by Chinese New Year.
Oh,
suppliers, but it still works actually, a print site.
Yeah.
So unfold it, we just lift off.
And then what's this button for?
So, as part of our prints we have here, we have a filament cutter that comes out there. That is not operated manually, usually.
Okay.
The printer at the end of a print will go, operate the filament cutter, drive it back, and position itself here.
Okay.
When this button is pressed, it allows us to unlock and remove the umbilical. But what it will also do, this machine's not plugged in, so it won't do it.
Yep.
But it will unwind the filament for you, so it just comes
so you can just pull it right out. Oh.
Straight out.
And that just pulls out, so they're just kind of friction fit.
Pulls out, exactly. Unlocks up here, drops down flat, and then we can go and store it in our travel case and take it anywhere you like.
That is so simple. Is this just like carbon fiber for reinforcement, or
this is actually circuit board.
Oh, that's a circuit board.
Circuit boards are fantastic engineering material. They're always used by electrical engineers because you can embed electronics into them.
Yep.
But mechanically, they're brilliant. It's fiberglass that you can get machined for incredibly low price with electronics built into it.
Okay.
It's
valid.
Not far off carbon fiber, you know. Now, should we go to the elephant in the room?
Sure.
That
is big, and I'm not going to pick it up with one hand because there's a lot of battery in that.
There are 90 18650s. This is a 1 kilowatt hour battery pack. Allows you to do 15 hours of printing with your printer on PLA, 10 hours with PETG, and 5 hours with ASA. There you go.
Underneath, so it locks in.
We have locking lugs on here, and then there's an expansion port at the bottom there. And that just drops in place and locks. And that's it. You now have a fully modular system.
And up to 15 hours of printing on the go.
Exactly. And this will be a fully modular system. So we have spool holders and even pull-out screens, so you don't need to bring a laptop with you and do your slicing on board on the Raspberry Pi.
Okay, that would be pretty cool.
That'd be very cool.
Now, these two are running. What do we have for screens here? This is a screen, right?
Yeah, it would focus on this one, shall we?
Okay.
You can't see it at the moment because obviously it's printing, but we have a fully haptic smart knob. So what this allows you to do, if you run your finger across that, you can feel it, actually.
Yeah. Oh, it's like resistive, yeah.
Yeah, but it's software programmable detemps.
Okay.
So when you get to if you want to change your temperature and up to temperature, it will be whereas if you're on off, it'll go.
Oh, nice.
So it gives you a really nice haptic feedback to control the printer.
And you're going to have to do that because obviously you can't really get at the touchscreen right now while it's printing.
Exactly, so it's not touchscreen at all. Okay. It's all run by that dial.
Now, for these printers, is the power supply internal, or do we have a power brick on the end of these cables?
It is fully internal.
Fully
There's
internal?
no power brick. Because that's one of the things we noticed with the Positron. Oh, it looks like a really great portable printer, but to have a 200 watt power supply that's an external brick, it's half the size of the printer, and it's incredibly...
I do believe some people have fit power supplies in it, but you have to do some heavy modding, and you lose some safety shielding doing that.
This is designed in from the beginning.
Okay.
So we will allow people to modify and maintain their own machines if they so wish. But we don't fully recommend it because having a full DC power supply can be quite dangerous.
Yeah, and especially if you're using it in a work environment, school environment, there's safety requirements and whatnot. So.
And the really interesting thing about this form factor of printer, being able to fit in a case this size, right? I mean, it's tiny.
Yeah.
You know?
That if you are traveling and you need to bring a printer on the go, like this will fit in your backpack in the overhead bin of an airplane, no problem.
Absolutely no problem. I'm taking this on a flight next week.
Yeah.
I've taken these on top of hills with a battery pack, put it for 8 hours on top of a hill, and funny enough, the cooling was the best I've ever had.
Well, you got that natural breeze.
Winds, yeah, exactly.
Oh, this is really cool.
I'm really excited for this because I think people are going to be taking printers places that no one's ever taken a printer before. You know.
It is very cool to see something that it started as an open source like community project, but take like kind of that idea of it and add, you know, actual mass manufacturing and refine the idea down, because while it is fun to DIY stuff all the time, it's always fun to DIY stuff. When you have a manufacturing capacity and you're designing stuff, you know, just sell it and go, you can do stuff that you can't do when you're trying to DIY it. For example, milled aluminum.
Exactly.
Not many people are milling aluminum at home.
It just allows the quality to just be so much higher.
Because every machine's going to be pretty much the same as well, because they're mass produced,
Exactly.
right?
And you know, there's nothing wrong if you want to build your own machine. Go build a Positron. It's great.
Yeah.
But most people don't want to do that. Most people don't build a laptop.
Yeah, if you're looking for the product itself and not so much the journey to get the product, if you're just looking for a compact folding printer to take on a work trip,
this is it. I hope this democratizes 3D printing further.
Yeah.
Because there's still a sect of people that don't have enough room at home or need a printer on the go that currently don't have any options. I think this could really be an option for them. So if you see here now, it will go and cut the filament for you in just a moment. There you go, automatic cutting of filament. And that's it. Our print is complete. And if you want to show you the unloading procedure now, we simply press this button. If you watch on here, it unloads your filament for you. And out like that you come.
Oh, nice.
Your filament comes straight out the back.
And it's unloaded.
And you're unloaded. It is really that simple. We've made this machine as easy as it is possible to use. You know,
and we do see here, you got the laptop running it, so it's running fluid. So this is running a customized version of the Clipper operating system.
Yes, it is. And we've modified it to try and make life as easy as possible for people. Full over-the-air updates, that sort of thing.
Yeah.
So you don't have to play around with SSH. You know, no one wants to do that. They just want a machine that works.
I'm assuming you're running a custom board on here?
Every single part of this printer is custom.
Okay.
There is nothing, you can't use like an E3D hot end on this. You have to do a customized nozzle. And if I show you the bed here, to remove your bed, it is that simple.
It just comes off.
If you feel that with your hand, it's quite hot, isn't it?
Oh yeah, it's going to be warm.
That is really quite hot. So this can go to 110 degrees. And I printed ASA on it, no problem.
Yep. And a fun thing about ASA, because this is upside down and heat rises.
Yes, if you use a draft shield, you actually keep a kind of pocket of hot air around it. So it's almost like you're printing in an enclosure. Because hot air rises.
So it's making its own enclosure, essentially.
Exactly. Well, there's no need to put the whole thing into a big enclosure. So you can do any material. And the really nice thing about this, because it's direct drive, you can do your TPUs.
Yep.
And that sort of thing.
We do have the flexible stuff here.
Yeah. And so that will just snap straight off like that.
And off you go.
And off you go and you can start printing again.
That's really cool.
Thank you very much. We think it's great.
Okay, so for those that are looking to get one of those, we're looking at around 1,000 British pounds.
1,000 British pounds.
And when will they be available?
In 2 months' time.
2 months' time?
We're launching a Kickstarter in 2 months' time. If you're interested, please go to MUON3D.com and sign up with your email there, and we'll get some more information to you about when that Kickstarter launches. You can get the early bird price. The battery pack add-on, if you're interested as well, will be a £500 optional extra on top.
And what voltage is it running at?
45 volt. And
45 volts?
45 volt, and that is what allows us to get such high speeds with these motors.
Oh, so you're running higher voltage motors, you're running the bed at 45. Oh,
exactly. Okay. So you can run at 600 millimeters a second with 20,000 acceleration, no problem. That's how you're getting, sub 10-minute benches.
That's cool. So thank you very much, Harry. You guys here at MUON3D, you're definitely turning 3D printing on its head. So cheers.
Thank you very much.
Cheers.
Take care.